Hello, Mrs. Boyd here, and today we're going to learn what a standard curve is, how to create one, and how to use one to find an unknown. So here's one that I just got off the internet for absorbance versus concentration. And you will notice that it is very similar to the one that you guys created in the lab. Your data came specifically from a spectrophotometer, and that was the absorbance. That's what you were looking for right there. And then your x-axis was the concentration of a bunch of Kool-Aid solutions. And you actually learned how to make those different concentrations and then took them over, and the spec gave you the absorbance values. So let's take a look at exactly how you go about creating one of these and then move into the second part, and that is how you use a standard curve. So we're going to move over to Excel here in a second, but I just want to make sure you know the data that I'm going to use is height versus wingspan. So I had a few people submit their height and their wingspan. So that is how wide they are when they hold their arms out. And I took a bunch of that data, and now we're going to pop it over here into Excel. That's where I want you guys to do all of your graphing, because this has all of the parts and pieces to make the graph and to get your equation and the regression and the whole deal. Okay, so first let's highlight all of our data for wingspan and height. And first you're just going to highlight it, and then you're going to click on Insert. Then after Insert, you're going to do a chart, and we're going to go down to the XY scatter. We're going to choose the first option for XY scatter, and bam, that's simple, and up comes a graph. So we are now going to choose layouts, and we need a regression, which is an equation of this line, because that's how we're going to be able to utilize it to find an unknown. So that's going to be the second up from the bottom, and look at that. It gave you the equation of the line, and it also gave you the R square value, which we'll talk about here in a moment. So once you have this done, the couple things you have to go in and do. This right now is currently, as you notice, missing units, missing titles. So you have to go back into Elements, make sure that you have axes titles on. Okay, it looks like you can edit both primary and horizontal axes. You also want to make sure that you have a chart title. Okay, so above chart, great. And then all you have to do is just click on it, and it allows you to just go in and edit that. So for the sake of time, I'm just going to assume that I have gone in and I have done my editing, including units. And now I'm going to copy this graph back into Notability. All right, so here it is right here. Change the thickness on my pen here. Okay, so let's go ahead and take a look at what the heck we're going to do with this now that we have it. So the first thing that we're going to figure out is we want to know if someone has a 68-inch wingspan. So I'm just taking a Y value. Your Y value is going to come actually off of your spectrophotometer, because you got an unknown Kool-Aid concentration. Right? And the spectrophotometer told you what the absorbance of it was, but it did not tell you the concentration. So your Y value is not something you pick at random like I'm doing here, but it is something you get off your spectrophotometer. For the sake of just showing you this example, however, I'm going to have us do someone with a 68-inch wingspan. And I'm going to show you two ways that you can use this graph and the regression to figure that answer out, because I want to know how tall they would be. All right, so first we're going to use something called the estimation using the graph. So estimation. And all that means is you're going to use the y-axis to find 68. And then we are going to go over, I like to also just snap a line and then try to go, oops, and then lift off it, and then let's go down and also snap a line. I'm doing this in Notability. There we go, get as close as you can. To me, that looks like maybe 67, let's see, 67 would be right about here. So 67.246, maybe 67.6. You're just taking your best guess. You notice this is not very accurate. So 67.6 6, and of course we always want units. Matter of fact, let's go back up and take a look. Yes, indeed, I have units here, inches. I have units here. These happen to be the same units. Yours probably will not be. Really important though that you have the correct units. Also notice I did go in and title it wingspan versus height. Graph titles are just very simply what is your X and your Y. Okay. So the first thing you did was the estimation. Hopefully that was pretty simple. The second thing you're going to do is you're going to actually do the calculation. And this requires this equation right up here. This is called a regression. It's the equation of the line. Y equals 0.9949x plus 0.5128. So this tells you, given any y value, you can find the x value on the line. Or for any x value, you can find a y value. All right, so let's use the exact same example. 68-inch wingspan. I want to know how tall this person is. What is their height in inches? All right, so let's go ahead and put the equation. And this is just some pretty simple algebra. We first take that 68 and we're going to plug it in for the y value. Now, why the y value? Because the wingspan is the y value if you look back up at your graph. Okay, so make sure you're putting it in the correct spot. So we're going to plug in 68 there. Then we set the rest of the equation equal to 68. And you can see how I went ahead and subtracted the 0.5128 from both sides. And then I had 67.4872 equals 0.9949x. To get x by itself, I'm just going to go ahead and do a division. Did that on my calculator and got x equals 67.83314. And then, of course, I had to round that off because we don't have that level of accuracy. So x equals 68 inches. So what that tells me is that the person who had a wingspan of 68 inches had a height also of 68 inches. Now the last thing you can do is you can compare your two numbers from your estimation and your calculation to see if they're pretty close. And sure enough, I have 67.6 inches from my estimation, and I have 68 inches from my math, and I noticed that those numbers are very similar, so we did them correctly. The final thing that you're going to be asked to do is to just evaluate how accurate your data is. So can we even use this data? Like, is the regression line pretty close to all of our data points? And so the way we do this is we look for an r-squared value, and you can see our r-squared value is right here. And so the key to evaluating r-squared value is how close it is to 1, to the number 1. So 0.9715 is dang close to 1. So yes, I would consider our data to be fairly accurate. You can say that it is not accurate if it falls below 0.9. Okay, hopefully that was helpful to you.